morning all. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about spatial and gray level resolution. So, spatial and gray level resolution is a digital image fundamentals. There are so many types of digital image fundamentals. So, what is the image fundamentals? The fundamentals, components or elements we need to converting from digital analog to digital. So, there are so many types of image fundamentals are there. Elements of visual perception, image sensing and acquisition, sampling and quantization, representing digital images, relationship between pixels, spatial and gray level resolution. In the previous sessions, these are completed. So now I am going for spatial and gray level resolution. So what is spatial and gray level resolution? Before going to the spatial and gray level resolution, we are discussing about image resolution. So, image resolution, a resolution can be defined as the total number of pixels in an image. This can be discussed in the image resolution. The clarity of an image does not depend on number of pixels, but on the spatial resolution of the image. So, the gray level resolutions refers to the predictable or deterministic change in the shades or levels of gray in an image, and gray level resolution is equal to the number of bits per pixel. Suppose I am taking one image. It is one example. So this image have some 56 into 56 pixels. Rows and columns are 56 into 56 pixels. So each one, it is called a pixel. So how many pixels are there? 56 into 56. So suppose this image have some intensity values. Example I am taking 126, 85, 120, 256, 0. I am leaving this one. So 20, 18, 120. So suppose total 56 into 56 pixels are there. Suppose I am not giving any intensity values for this one. 1, 2, 3, 4, 5. So total number of pixels 56 into 56. But some pixels I am not giving any intensity values because we don't have any intensity values for that one. So total number of pixels and number of intensity values are different. So when this image I am giving some intensity value, this intensity value I am taking as a gray level values. These are called gray levels. So the image with the pixels with the intensity values I am calling as these are the gray levels are there. So here gray levels are there. The image which have a gray levels are there. So that is the process is going as a spatial domain filtering, spatial domain process. Okay. So this image with 56 into 56 pixels, in this 56 into 56 pixels, how many pixels we have gray levels are there? How many pixels we have gray levels are there? So this process I am calling as a spatial domain. This process I am calling as a spatial domain. So in this spatial domain, we are applying the gray levels. That means intensity values. I am giving some intensity values to this one. So how many pixels are there? How many intensity values are there? So that is a gray level. So the pixel with intensity values I am calling as a gray levels. So total number of pixels, total number, how many intensity values are there. Suppose here I am taking some 52 into 52 intensity values are there. So I am calling as it is a spatial domain filtering. So here they are telling that image resolution. A resolution can be defined as total number of pixels in an image. So total number of pixels, how many? Suppose I am taking here 56 into 56 pixels are there. So it has been discussed in the image resolution. The clarity of an image does not depends on number of pixels. So it does not depends on number of pixels. So how many pixels are there? Suppose 56 into 56 are there. Okay, example 1026. Example. So does not depends on number of pixels. How many are there? Here 1026 pixels are there, but on the spatial resolution of the image. So spatial resolution does not depends on total number of pixels or total number of intensity values. So in these 1026 values, how many intensity values I am applying? So 980, suppose I am taking 980 values are there, 980 pixels with intensity. So in this 980 pixels with intensity values. So total 1026 pixels are there, but in this 1026, how many intensity values were applied? So 980 pixels were applied. So these 980 pixels with intensity values I am calling as a gray level. The total process I am calling as a spatial resolution. So the spatial resolution of the image. So total how many in that total number of pixels, how many pixels or intensity values are there. So that is I am calling as the process is called spatial resolution. So spatial resolution is completely depends on gray levels. So gray levels are nothing but intensity values. Intensity values. So gray level resolution. Gray level resolution refers to the predictable or deterministic in the shades or levels of gray in an image. Gray level resolution is equal to the number of bits per pixel. So the total number of 980 pixels are there. So how many bits you are applied? So these gray levels depends on resolution is equal to the number of bits. How many number of bits you are applied for that one per pixel. So bits per pixel, BPP. How many bits per pixel? The number of different colors in an image is depends on the depth of the color or bits per pixel. Suppose I have the image is there. Okay, this is a light red. It is a dark red. So there are different colors are applying for the image. So the number of different colors in an image depends on the depth of the color or bits per pixel. What is the depth? Light or dark or medium, whatever may be. So depth of the color or bits per pixel. It will be depend on BPP is depends on depth of the color or bits per pixel. So there are different colors we are applying. Suppose we are taking RGB, red, green, blue. So it is a one color combination RGB. So in this RGB, how many red in intensity values are there? How many green values are there? How many blue values are there? So total I am taking as a combination of RGB. So the RGB color combination, what is the depth of the color and what are the bits per pixel? Okay, I am taking suppose 101 like this. So mathematically how we are taking the mathematical relation that can be established between gray level resolution and bits per pixel can be given as L equal to 2 power k. So the mathematical relation that can be established between gray level resolution and bits per pixel. So what is a gray level resolution? So in this pixel, in this image, there are so many intensity values are there. So there are so many gray levels are there. So between the gray level resolution and bits per pixel. So bits per pixel, that is the relation between the bits per pixel and the gray level combination. That is a L equal to 2 power k. So here L is refers to the number of gray levels. Here K is refers to the BPP or bits per pixel. So number of gray levels. Suppose in my image, suppose 120 pixels are there with gray levels. Suppose I'm taking 128 or 120 is equal to 2 power. So 120 gray levels are there in my image. Then 2 power. How many bits per pixel? How many bits per pixel means? Suppose in my 3 bits per 3 bits per pixel is there. So 3 bits means 2 cube. So 120 equal to 2 cube. Suppose I don't know the K value. So L equal to already I know 120. So 128 I am taking example. So 128 equal to 2 power K. How much value of K? So shall we find? Yes, it is possible to find out. So here what is the relation of L equal to 2 power K means L equal to number of gray levels. So how many are there? How many pixels are there? Here that image is a 1024 are there, but total number of pixels are 1024. But how many gray levels are there in that one? Suppose 980 gray levels are there. So 980 is equal to 2 power number of bits per second. Number of bits, how many are there per pixel? So 3 bits per pixel is there. So 128 equal to 2 cube, like. So in this equation, L is a number of gray levels and it can be defined as the shades of gray, and K refers to the bits per pixel. So the 2 raised to the power of bits per pixel is equal to the gray level resolution. So it is one example of image. It is one example I am taking as an input image. This is the input image. So what is the resolution for of this image? So if you are increasing or decreasing the resolution of the image, what will happen? Suppose in the above image, the grayscale image means it is an image with 8 bits per pixel or 8 BPP. Example I am taking 8 bits per pixel. This image has a 8 BPP, bits per pixel. Example. So L equal to, already we know that L equal to 2 power K, where K equal to 8. Why I am taking 8 here? 8 bits per pixel is there, 8 BPP is there. So K equal to 8, L equal to 2 power 8. So L equal to 256. So how many gray levels are there? Total 256 gray levels are there. 256 gray levels. So this image has a 256 gray levels. So it is one example. So it means its gray level resolution is 256, or in other we can say that this image has a 256 different shades or gray. The more is the bits per pixel of an image, the more is its gray level resolution. So the defining a gray level resolution in terms of bits per pixel, it is not necessary that a gray level resolution should only be defined in terms of levels. We can also be define it in terms of bits per pixel. So in this image, how many gray levels are there? So we have to find out. So they given that the image has a 8 bits per pixel. They given 8 BPP is there. Already we know the formula L equal to 2 power K, K is equal to 8. So 2 power 8, L equal to 256 gray levels are there. But in this figure, the 256 is the other can say that the image has a 256 different shades or gray levels are there. So 256 shades or gray levels are there. This more is that bits per pixel of an image. The more its gray levels is the resolution. Suppose I have to increase 256 to 512. How it is possible means I'm increasing the BPP. If I'm increasing the BPP, then resolution or gray level values will be increasing. So it is not necessary that a gray level resolution should only be defined in terms of levels. We can also define in terms of bits, not only in terms of levels, also in bits per pixel. We have to define in the bits per pixel, not only in the type of gray level. Okay, not only in the gray level, we have to show in the bits per pixel also. So finding bits per pixel from gray level resolution. We can also find the bits per pixel from the given gray level resolution. For this, we just have to twist the formula a little bit. So suppose I'm taking, already we know that L equal to 2 power K. This formula finds that the levels, and it can also be find the bits per pixel, or in the case k. So we can simply the change it like this: k equal to log base 2 of L. So to finding out the bits per pixel from the gray level resolution, how it is means, first I am taking as a L equal to 2 power k, already predefined in the previous one, and this formula finds that the levels, and we can find the bits per pixel. In case of k, we will simplify, change it like this: k equal to log base 2 of L. So I am applying reverse order here: k equal to log L base 2. Okay. And because in the first equation, so here what is the k value? Bits per pixel or not? Yes. Here BPP is equal to k is equal to log L base 2. In the previous we discussed L equal to 2 power k. So gray levels equal to 2 power k. But here I am taking BPP is equal to k is equal to log L base 2. Okay. So this equation is finding out the gray levels, and this equation is to finding out the BPP. So here BPP is equal to k is equal to log L base 2. So because in the first equation the relationship between levels L and bits per pixel k is exponential. So is it exponential or not? BPP is equal to k is equal to log L base 2. So I am taking here, because of the first equation, the relationship between L and k are the exponential functions. We have to revert it in the inverse of the exponential is log, and have to take an example to find out the bits per pixel BPP from gray level resolution. For example, I am taking here in the previous slides, two examples are there. First one is a L equal to 2 power k. In the reverse order, I am taking as a k equal to log L base 2. So it is one type of equation, it is another type of equation. Okay, inversely proportional of this second equation. So it is I am taking, for example, the given image has a 256 levels. What is the bits per pixel required for it? We have to taking as a 256 equation. So k equal to log L base 2 logarithmic of, what is the k value here? Already we know that here k equal to log base 2 of 256. Here k equal to log L base 2. What the values are they given? 256. The value they given that 256. So L equal to 256 already they given. So it is a 256. K equal to log base 2 of, what is the 256 value? 2 power 8. So the 2 power 8 equal to 256. Log 2 of 2 power 8. So what is the value equal to? 8 log 2 base 2. So here k equal to log 2 base 2 equal to 1. So 8 into 1, k equal to 8. So here k equal to 1, 8. So the answer is the 8 bits per pixel. 8 bits per pixel, 8 BPP, 8 bits per pixel. So if we know the L equal to 2 power k, we can find out the L value. If we know this value k equal to log L base 2, we can find out the k value. K is equal to BPP. Here L equal to gray levels. If I want to find out the gray level, L equal to 2 power k. If I want to find out k level or BPP equal to k equal to log L base 2. So it is a equation. And another one, gray level resolution and quantization. So what is the need of gray level? Already we know the gray level resolution, but what is the relation to the quantization? So gray level resolution is to find on the y-axis of the signal So it is introduction to the signals of the system. We have to study the digitization of the analog signal required to two steps, that is the sampling and quantization. So if you know the sampling and quantization, previously we discussed sampling and quantization. What is the use of sampling and quantization means? Suppose I am converting to the analog image into the digital image. So if I want to convert the analog to the digital, I need sampling and quantization process. It is an input signal. So it is a system, that is a sampling and quantization. It is an output signal with a binary. It is also called 1 0 1 0, like so on. So here the sampling is done on x-axis and the quantization is done on y-axis. So total I am taking x and y-axis. Here x-axis is for sampling, y-axis I am taking for quantization levels. So that means of digitization, the gray level resolution of an image is done in quantization. So the digitization of the gray level resolution of the image is done in quantization. So sampling is simply converting to the number of samples, but quantization is applying for the digitization of the gray levels. Digitization means we are converting to the binary in the form of binary values. That is the digitization of the gray levels in the form of quantization. So digitization of a signal. So the digitization of an analog signal into a digital, we require two basic steps, sampling and quantization. So sampling is done on x-axis and y-axis I am taking as a quantization. So here it is one example, sampling of a signal. X-axis I am taking as a time, y-axis I am taking as a voltage. Sometimes I am taking as an amplitude also. So time with amplitude or time with voltage. So these are the number of samples. These are the number of samples. So how many number of samples are there at x-axis and y-axis? So sampling of a signal means how many samples, x-axis and y-axis. So the sampling sample points. So how many sample, each one has a sample point. So total how many sample points are there? Total 8 or 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 sample levels are there. So sampling of a signal means the input image, the input is like this. So input image, so it is a time and it is a voltage. So suppose I am taking number of samples. How we are choosing this one means TS, 2TS, 3TS, 4TS, 5TS, so on, 6, 7, 8, 9 TS. So how many time samples are there each? So first TS seconds, what is the sampling level? Second 2 TS time, what is the sample level? 3 TS, 4 TS, so 9 TS. So each have the time. I'm dividing as a time 0, 1 second, 2 second, 3 second. Like TS equal to, suppose I'm taking TS equal to 0.1 seconds. Okay. So first one is a 0.1. 2 into 0.1 means 0.2, 0.3 seconds, 0.4 seconds, 0.5 seconds, so on 0.9 seconds. So at the time of 0.9th sample, what is the value? Okay, like this. So each I'm dividing as a time samples. Each time sample, what is the amplitude level? So first times 0.1 seconds, what is the level of the amplitude? Second time second, what is the amplitude? Third time second, what is the amplitude? So I'm taking as a sampling of a signal with number of samples. So x-axis is a time and y-axis is a voltage. So the sampling with relation to the digital images. The concept of sampling is directly related to the zooming. So the more samples you take, the more pixel we will get. So oversampling can also be called as a zooming. The digitization as a signal does not end sampling too. There is another step involved which is known as a quantization. So number of samples are depend on the quantization process also. So the sampling is directly related to the zooming. What is the zooming? We will discuss. The more samples you can take, the more pixels we will get. So number of samples are increasing. Number of samples you can take, more pixels we will get. So more pixels also increasing. So the oversampling can also be called as a zooming. So when applying the zoom, suppose I have an image. So I have an image. Suppose I'm applying the zooming for this one. So first these pixels, 3 into 3 pixels, I'm applying the zooming. Zooming for 3 into 3 pixels. So in applying the zooming, what will happen? It will showing as a more number of pixels in a particular image. So this 3 by 3 I'm talking as a much pixels. It is showing as a much pixels. So if number of pixels are increasing, when applying the zooming, number of pixels are increasing. So when it is a number of pixels are increasing, number of samples will be increasing. So number of samples are depending on you are applying the zooming. Suppose it is a 56 into 56. I'm not applying any zooming here. So there is a nothing will be changed. 56 into 56 are there. But if I'm applying the zooming means it will be increasing. So more than 56 into 56 it will be increasing. So more number of samples also increasing with the zooming technology. So the digitation of the signal does not end at sampling 2. There is another step involved in showing as a quantization. So here only I am discussing samples with pixels, but also it will be depending on quantization also. So quantization also, sampling and quantization are depends, it will be change the gray levels. Gray levels will be changed with the sampling and quantization. So quantization is opposite to the sampling. Okay, it is I'm taking as a y-axis. In the x-axis, y-axis, x-axis I'm taking as a samples, y-axis I'm taking as a quantization. So when quantization of an image, we are actually dividing a signal into the quanta or partitions. So number of input is a quantization input is a samples. So quantization is what it is doing here means number of partitions means quantizations or quanta. The x-axis of the signal are coordinate values and the y-axis are the amplitude values. Already we know that x-axis are the coordinate values, y is the amplitude. So y is the amplitude, x is the coordinates. So x-axis is a signal out of the coordinate values, y-axis is the amplitude or voltage values. So the digitation amplitude is known as the quantization. So digitation amplitude means y-axis is amplitude or not? Yes, y equal to amplitude. Amplitude means I am taking as a quantization. So x-axis I am taking as a time. So number of time samples means it is as a taking as a samples. X-axis is a time, that is number of samples. Y-axis is amplitude, that is quantization. So here x-axis and y-axis are there. So x-axis is the number of samples I am taking here and y-axis I am taking as a quantization. So it is one output waveform. It is one output waveform, that is the with sampling and quantization levels are there. It is one example of sampling and quantization. Samples are with x-axis and y-axis are the quantization levels. Okay, so it is the sampling and quantization output. So what is the input for this one means? It is a input and it is a output. So analog is converted to the digital, or another form of this one means continuous signal. Continuous signal is converting to the discrete signal. So it is in the form of binary. Okay, it is 1 0 1 0 so on. Okay, So the waveform with the square waveform with the values of binary values, that is a digital or discrete signal. The input is a continuous or analog signal. Okay, it is the x-axis and with y-axis, sampling and quantization levels in x-axis and y-axis. So the sampling and gray levels are depends on, so the gray level values are depends on sampling and quantization. So the quantization has 5 different levels of gray. It means that the image is formed for the signal. It has a 5 different colors are there, and it would be black and white image or more or less than with some colors of gray. Now, if you were to make the quality of the image more better, there is one thing you can do here. So to increase the levels of the gray level resolution up, if increasing the levels of 256, it means you have to increase the gray level scale. So which has far better than simple black and white image. So suppose I am taking suppose I am taking 56 into 56 pixels. So the quantization have 5 different levels of gray. It means that the image formed with the signal, we have 5 different colors are there, and the black and white image are less with some colors of gray. Now we are making the quality of the image more better. There is one thing you can do here, that is increasing the levels or gray levels resolution up. So we are increasing the resolution up, the more better, and we are increasing the levels of the gray level resolution up, the increasing the levels to the 256. So what is the values of means 256 pixels. So if you are increasing the pixels, the resolution also increasing. So which is far better than simple black and white image. So it is a one example for simple black and white image. I am taking as a black and white simple. So this simple black and white, you are not going for the much contrast or much colors combinations. So we are going for the simple black and white color with the resolutions are increasing, then pixels are come under normal, that is a 256 pixels. So now we are taking either 256 or 5 different quantization levels. Choose is called gray levels. So suppose I am taking 256 or 5 quantization levels. Here we discussed 5 different gray levels or 256 resolution values I am taking. So in the gray level resolution, we have discussed that gray level can be defined in 2 ways, which were in these. So gray level equal to number of bits per second. So that is a bits per pixel, k equal to bpp, and here number of levels per pixel, number of levels l equal to 2 power k. There are 2 different ways to find out the number of pixels or here number of bpps. So what if I want to find out the bpp, then I am taking as a k equal to log l base 2. If I want to find out the gray level number of pixels, l equal to 2 power k. So there are 2 different ways to find out the gray level values or bits per pixel. So in this case, we have taking the gray levels or the 256 levels I am taking here. So we have to find out how many bits are there in the 256. So simply the equation is a 256 levels or means 256 different shades of grays, that is a 8 bits per pixel. Hence the image would be a gray level. So here 256 means 2 power 8. So 8 bpp. 8 bits per pixels are there. Suppose I want to reduce the gray levels. Now we are reducing the gray levels in the image, in the effect of image, that is, for example, I want to reduce the 256 into the 128 like this. I want to reduce gray levels. So the image with 8 bits per pixel, that is a 256, 2 power 8 means 256 different levels are there. So the grayscale image as the image looks something like this. Suppose the 256 gray level, the image is showing like this. next image I am taking as a 128 gray level. So 128 is the 50%. Okay, so I am reducing the 256 to 128. So 50% I have decreased to 256 gray level to 128 gray level. So there is not much effect of image after decreasing the gray levels to this half. Let's decrease some more. So there is no difference. No difference in image to reduce gray levels. So I'm taking another one. It is I'm taking the 64 gray levels. Still not much effect than the reducing the levels of merge. So I'm taking as here it is a 64. There is no change in gray level. Here I'm taking 32. Is it any change? There is no change with 32 gray level. So here the contraction level has a 5 different levels I am taking. There is no change in the image of the signal. 5 different colors. If I am taking it as a black and white, then I am taking as a normal simple black and white. There is no change. If I am taking the 256, there is no change. So L equal to 2 power k. So here L equal to 2 power k means 256 equal to 2 power k. Here what is the k value here? K equal to 8 bpp. Suppose here I am taking 256 gray levels, that is 8 bpp. There is no change. Here I am taking 128. So the bpp will be changed. Yes, the bpp will be changed, but there is no change. Here 64 bpp. So 64 means bpp value will be changed. Yes, but there is no change in the image. If I am taking 32 gray level, still there is no change in the image. So if I am changing the bpp value also, there is no change in the image. So that is the advantage of the applying the sample and quantization in the gray level resolution. So it is a discussing about spatial and gray level resolution. So in the digital image fundamentals, already we discussed elements of visual perception, image sensing and acquisition, sampling and quantization, representation of the digital images, relationship between pixels, spatial and gray level resolution. So we are completed spatial and gray level resolution today. So total image fundamentals are completed. So if I'm changing the gray levels or if I'm changing the BPP, there is no change in the original image or gray level image. Why? Because because no change of the image. Why? Because I'm changing the BPP also. With the help of sampling and quantization, if I'm applying sampling and quantization, there will be nothing change if I'm changing the BPP value also. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.